Okay, so we're gonna keep the one that was posted before, and I use the email.
Yep.
And then everybody should be able to get on. Thank you.
We're hopeful that we're going to have a series of presentations every other week. I don't know how, we may stay up on top of that. It might be spread out a bit, but our goal this year is to really have a set of either workshops or presentations and events every other week. And we'd love to be able to engage the community more despite COVID. We'll be doing things to make our environment here even more safe with COVID. We're going to be building some carrels and things like that, some dividers of plexiglass. Boys and girls will start up in September again this next week. We're going to have a Battle of the Bots again with the middle school this year, which is tremendous. And then we're also going to be building a StoryCorps booth and starting up a relationship, hopefully, with our local historian and museum. So there's a lot of good things planned for this year, and we hope to see you all back here again. Thanks, Walter.
Okay, so I'm Walter. I'm going to be presenting today. And thank you, Teresa, for that introduction. So today we are going to be 3D printing this item, which is a chip clip, but you could also use it, to clip almost anything. And this was printed in one print, and it has a hinge in it and a little ratchet. And we've printed a bunch of them. And one of the things that we've noticed is, and this is sort of a don't be afraid of this because it's always a learning process. And I came to 3D printing some number of years ago, but really fell out of it and got back in because of the shortages of masks that we had at the very beginning. And so hooked up with these folks and was able to pretty quickly figure out how to go about printing something, but you wind up with errors. And so just don't be afraid of that. It's going to happen. And so you wind up sometimes with something like this. And obviously not what we were shooting for, but that does happen. And you learn along the way. We've also noticed that printing these with the black filament wound up with a lot worse success rate on sort of breaking them free. And that for whatever reason, the red wound up being a better choice. So with that, and one more note. So this item is a what's known as an STL file, .stl, just like you would see like .jpeg or .doc or .exl or XCL. It's just a type of file. And it has to be imported into a program and then sliced for your specific model of printer. And so today we're working with the Ender 3D Pro, and it is or the Ender 3 Pro, and very inexpensive printer. It works really well. As you'll see, we've printed a bunch of these. But again, you can find these STL files on the internet for free. people have already gone out and designed these things, and there's libraries of thousands and thousands of items. This is just one of the useful items we found. We've got some piggy banks here. There are you can find, for instance, a toothpaste attachment to your toothpaste that automatically winds up the toothpaste, so you don't wind up with any toothpaste left in the end. So there's a host of useful items, and if you come into the STEAM Center, we've got 2 Ender 3 Pros, and they're available for your use. So to use them, again, you will need software, and the software that we found that works best is Prusa Slicer, and this came from a gentleman that helped us out while we were working with the sort of the mask team to get masks printed. And so this is the software that you wind up using. And Stephen, are we going to be able to have the TV screen here? Yeah, just because the folks in the room can't see this. Thank you. And everyone, address the, is this technically rich? It looks like it's on.
It's on the other side.
I got it. And that is HDMI 1. So while he's working on that, what is going on here? Okay. So while he's working on that, so I'll just talk about, so one of the most difficult things with these Ender 3 Pros is what's known as bed leveling. So this bed, it doesn't automatically level. It is, there are 4 wheels. So there's one wheel here, another here, here, and here, each corner. And if you turn this wheel, it is going to raise that corner of the bed up and down. And so in order to have a clean print, you really need a level bed. It's probably the most important piece of this. So let's see if I can get closer into here. And Stephen, maybe if you want to just come around to my computer and see what needs to happen.
Can you share the display to both the Zoom and the
There we go.
monitor so that people online can see?
Are you able to see that?
Not on Zoom yet. I think he's got to toggle something.
Okay. It makes everything a little bit more difficult to see. So this does not look exactly like what the software looks like if you're in not connected to multiple displays, but you can see here, these are going to be your options, and then down here there's a button. You can barely see it, but it says Slice Now. So what I've done is I've imported that .stl file, and it's going to output a file that is, again, specific to this printer. And so for these printers, what I'm doing is I'm using this small USB dongle. And for folks at home, I am showing that on my camera screen. If you toggle over to my camera screen, you should be able to see what I'm using. It's just a micro SD card to USB. And that gets plugged into the printer right here. This guy right here. So literally what I'm going to do is I import a file into the computer, from the internet or somewhere that I've created. I'm going to go in and sort of massage it just a little bit. It's pretty simple. I click Slice Now. It creates a new file that I then upload to this card. That card goes in the printer here. And then we are one step closer. So I'll run through that just a little bit in a little bit more detail. So some of the settings here is the first setting you have here is sort of going to be your speed. So our options here, and I know you can't see this very well, it says detail, normal, or draft. So draft is going to be the quickest print speed, normal is your medium, and then detail is obviously going to be the slowest. And so it's just a question of what you need. We printed all of these on a normal setting, and they take about 40 minutes. And if you do the detail setting, it's about an hour and 10 minutes. And if you do the draft setting, it's closer to 25 minutes. So, depending on what you needed or how long you wanted it to last, sort of would dictate how quickly you print it. So I'll go ahead and select normal. And then the second question here is filament. And so we've selected generic PLA. There's a load of different types of filament that you can buy. PLA is most of what we have here in the steam engine. So if you want to come print something, you're going to be clicking PLA there. The next is the actual printer. So here we've got the Ender 3. So we're going to click that Creality Ender 3. So the next thing that you can do here is you can move this guy around, and there's all sorts of manipulations that you can do with this. So for instance, if I click in this left-hand toolbar, I can click something there. I can turn it so that it will print, vertically. I can if I go to this guy, what I can do is, or so this bottom button, I can actually extrapolate this up or down. So I can make I can just augment the specifics of that STL file within this program. All of those you can play with them. But the most important thing you have to realize is that you're printing something on a flat surface. So you want to look at the object that you want to print, and you want to find the largest flat surface on that object. And then you want to place that up against the bed with respect to in this program. So you would not want to print this basically in any other orientation than what you see here. I'm sorry? No, the pigs were printed just this way. Yeah, the same way, just like that. And for instance, the masks that we printed, it was sort of the farthest away from your face ended up being face down. But there are some objects where you can print them in multiple orientations. And the other thing we could do here is you could actually print probably about 4 of these in one print, right? So I could actually import this file 4 times, and it would show up here in 4 different iterations of it. And then when I slice it and it creates that new file type, it would go, and the printer would print 4 of these in one go. Now it's going to take much more time, but probably slightly less time than printing them individually. And thank you for your question. And if anyone else has questions, please do interject. And on that note, because we want to make this fun and educational, we have some questions, and people that get the questions right will get one of these clips, or a pig, or a dog. Okay, so the first one is fairly easy, I think. What kind of rock is obsidian? A, sedimentary, B, metamorphic, C, conglomerate, or D, igneous? Very good. All right, you ready? No, you don't need to raise your hand. You have the first chip clip. Okay, so and again, just to stress this file, I Googled and I just said interesting things to print, and there was a list of 55 different things to print that you might be able to use in your everyday life. And I went and selected this one. I downloaded the file, I imported it to here, and that was basically it. And after really, it's 2 clicks. I check the normal, what speed do I want, what type of plastic, and then what type of printer. And then I go, how do you, so I'm going to get to that. That is the next step. So now you can see once I did slice, you can sort of see it looks different now, right? It's not green and sort of the inside is red looking and the outside is yellow looking. So that is an indication that you have effectively sliced it. And so now in the bottom right-hand corner, instead of saying slice, it says export G code. And so that's exactly what you would normally do. You would go and export it. I've already done that, but you would export it to your USB, and then you would withdraw it and put it in the printer. This is also a good time I often take to rename it. Often when you download these files, they have very long names. Like this one is Pinzas Print Palace Ratchet, right? So it sort of tells you where it came from. And so we don't really need that information. So I would delete that so that when I go and look for it on this device, you're going to see the word ratchet. So I'll just save that into downloads. Welcome. Okay. So that is really, that's the basics of Prusa Slicer. And this computer has Prusa on it. If Prusa is not on one of the devices you find, you can Google it and download the slicing software. It's free. There's also a host of other slicing softwares out there, and these devices are software agnostic. They can print several different types of, they can print G code, they can print 3MF files. And so if you find a slicer and you can find the printer within the slicing software, you can use that. This is just illustrative, right? So you can find different software that you like better. This is just what we found works better with the enders. Are there any questions about Prusa or the slicing process? Okay, so I think I'm gonna take this out. I don't think I have anything else to see up there. And okay, I will stop my screen share. And so for the folks at home, I don't think you could see me at the time, but so this is the device that actually came with the 3D printer. If you take that out, this is just a USB device. On the backside, you have a slot for the micro SD card, and the micro SD card can be inserted and removed from the slot and placed into the printer. So that's how you download or export information from your computer onto the micro SD card, and then you place that into the printer. So with that, we will turn to bed leveling. Actually, first, we're going to ask another question. All right. What blood type is the rarest in humans? A positive, B negative, AB negative, or O positive? Okay, who said that? I heard a couple. Okay, you get the win. Would you like a piggy bank, a little puppy dog, or a clip? All right, here I can bring this out to you. Okay, get that. All right, so bed leveling. So again, I would say this is the most important part, or maybe just the most. It's just the most important part of the printing process, because if you don't have the bed really close to being perfectly level, your print is not going to come out quite right. You really need this bed to be level. There are fancier printers that have auto leveling beds. Neither of our printers have that, and this allows you to get a sense of or have control over sort of where the things end up. So the first thing you're going to do is you come down to prepare, and you say auto home. And maybe, I guess there's not a way to share that screen to here, is there? If y'all want to, well, yeah, I mean, y'all can, everyone that's here in person, you can come and play with this later. this knob here is how you scroll through the menu. We have an LCD display here. It allows you to go in and select files in your micro SD card, but it also allows you to move this the nozzle head and the printing platform around. And so all of that is after you, it's just a wheel that you click, so you can scroll through things. And so most of the things that you want to do, and when you're doing bed leveling, is under sort of the appropriately named category, prepare. So we want to prepare. So the first thing I did was I clicked auto home. So auto home is task number 1, and that means that this nozzle is right here on top of this piece of paper, and I can actually feel that piece of paper is pretty stuck on there. It looks like this bed got a little bit kicked out of the way, and what you want is you want firmness, but you don't want it to rip the paper. So that nozzle head where it's reaching down, it should just be snug, but not so snug that you're ripping the paper. So then the next step is, so you're at auto home. The next step is disable steppers. And what this allows you to do is you click disable steppers, and this allows you to move the print nozzle and the bed platform independently of the motors without damaging them. And so we can go and just move this across. And as I'm moving that across, I can feel that it's loosening up. And so I want to loosen that a little bit more. And then I can bring the bed forward. I can feel it starting to get tight. So I want to lower this back corner. And then I'm going to loosen it, and I'm going to tighten it back, and I'm feeling. As we get there, it's loosening up just a little hair. We go until it gets firm. I'm coming across, and that feels pretty good. So what I'm going to do, I'm just going to pause. I'll throw on my mask. If anybody wants to come up here and just feel how that feels, that piece of paper feels, that may be useful if you want to come print. Anyone want to come do that? You feel that?
It's actually pretty tight.
It is. It's pretty tight, but it's not ripping the paper.
Can I move the wheel or?
Certainly, you can try that out if you'd like. So you don't want to move that wheel. So the corner that you're in is the wheel that you would want to move, right? So wherever the print head nozzle is closest to is the wheel that you would want to move. So if you wanted to adjust it a little bit, so if you spin the wheel towards you, it's going to drop the bed, and if you spin it away, it's going to raise the bed. And that's
Righty tighty, lefty loosey.
righty tighty, lefty loosey. Absolutely.
Okay.
Okay. Yep. Okay. Absolutely. Okay. So yeah, it's snug. Snug.
Okay. And where, oh, there's that wheel there.
Yeah. So we got one in each corner. Exactly.
Okay.
And then
So you got the 3D.
yeah. So it's a little bit weird when you go and adjust one. If you ever have adjusted one of these wheels, you really want to go and check around all 4 corners, because anytime you adjust one, it changes the other 3 ever so slightly. So if you put your hands a little closer up there, yeah, there you go. There you go. Here, try it like that. All right. Anybody else? All right.
And so when it's in that mode, you can move
You can move this back and forth.
And the table.
Exactly. So the only thing that you can't really do is you can't raise and lower this. It's on a worm drive. So that is not disabled, but you can move the print head nozzle and the bed. Okay.
But you theoretically shouldn't have to move that.
Exactly. So because we've moved these, I'm gonna come through and I'm gonna check again. Just do some fine tuning, and it's once you get to the fine tuning. I mean, you're moving these wheels, just a 30-second of a turn, or less. So that one's a little tight. So I'm gonna come over here. That feels pretty good. Come up. That's feeling a little tight. That feels good. Come over here. And then what I'll do is I'll do a final pass on the inside, because that's where the ultimate print is going to be, right? The print is going to be right in the middle of the bed, not on the corners. So I'll come up, try it out here. And it feels just a little bit lighter in this corner. So I'm just going to give myself one last little tug. That feels pretty good. That feels pretty good. That feels pretty good. That feels pretty good. So that is that. And no ripping of the paper means you had a successful leveling. And anytime you move one of these printers, or if you come up and just knock it, you'll need to tweak it ever so slightly. So I'll go back and go to Auto Home. And so I'll just note there is one other way to do bed leveling, and it's a little bit more laborious, but it can happen. And so right above, so on this main screen under Prepare, we've got Main, Move Axis, Auto Home, Set Home Offsets, or Disable Steppers. So what we just did was Auto Home and then Disable Steppers. Another option is you can move axis. And so then you can actually just go and move on the x-axis, and I can, with my wheel here, I can move it around. And I can keep my piece of paper under there, and it's a little bit more of a controlled movement. It takes longer, but it is, it's nice for a little bit of a finer touch. You can sort of move back and forth and know exactly where you are. So if you have a complicated print, that may be something you want to investigate. Okay. So now that we have so we've downloaded the file from the internet, the STL, then we've exported the G code, and we put it in on the micro SD card. We've got the micro SD card in here. We've leveled our bed. After doing everything, we clicked Auto Home one more time. And then we're going to go up, and it's on the very main menu, it is, we've got another person who's arrived. Hello, Anna. So on the main menu, we've got info screen, prepare, control, and then print from TF. So if you go to print from TF, you're going to see a series of options. And basically what you're doing is you're just looking at your micro SD card. That's it. So your micro SD card is in here. And so we're going to go down, and I will find our ratchet, which is right there. And that's why I renamed it. And what is going to happen now is, so the bed is going to heat up to 40 degrees. Is that, I guess those are centigrade. Yes, centigrade. And then 215 degrees here at the nozzle. So that takes a little bit of time. So I've pressed print, and basically what's happening now is that this whole apparatus is just warming up. While you're leveling the bed, you can actually preheat the bed and the nozzle. You just have to be careful, more careful, because the nozzle is very, very hot. So you don't want to reach your finger in there and burn yourself. And you'll also notice that you'll get a little bit of extrusion. Some of this filament will start to pour out of there a little bit. But if if you're in a hurry, you can certainly preheat the bed, and that's pretty self-explanatory in those codes. And that brings up another point, and this goes back to the software. So if you're having print problems, right? So if you're winding up with stuff like this, it means very likely one of two things. One is that your bed isn't level, or two, that your extrusion temperature, there's something wrong with your extrusion temperature relative to the temperature, the ambient temperature, right? So if you're printing in a room that's 50 degrees Fahrenheit, you're probably going to need something that's either a little bit hotter or a little bit cooler than if it's 70 degrees. And that's something that you have to experiment with. So you want to be mindful of the ambient temperature. And so within the slicing software, another set of options that you can tinker with is the bed temperature as well as the nozzle temperature for your particular print. And so, for instance, you may want a slightly higher bed temperature if the thing that you're printing has a brittle surface where it meets the bed itself. So you can see now the printer is beginning its print. So the first thing it does is it comes along the left edge of the printing platform, and then it's going to start laying a line. And this is sort of your line saying, hey, it looks like I leveled this bed correctly because it's attaching to the bed. There's a straight line. There's no cracks or weaves or bubbles or anything in it. And then the second thing that the printer is going to do is it's going to print a perimeter around where your print is going to happen. So right now it's laying down a perimeter, and this is one of those things that I tend to end up watching because if this first layer goes well, usually the print will be just fine throughout. But the first layer is sort of the most worrisome layer. It's the layer that if it doesn't quite work right, well, maybe I just scrap it and I'll start over again. And so, what you want to watch out for is just, extraneous stuff, right? So as soon as you start seeing anything that looks like this, you've got a problem. And it's best just to go in there, you hit cancel, and you just restart and tinker with it a little bit. You got to say, well, what didn't go right here? What exactly went wrong? And especially if you're sitting there watching at the very beginning, you're going to have a fairly good sense of what may have gone wrong. Yes. Abort? Yeah. So that is right here, and so so this is the information screen. So what you see right here is what is always there. If it's in the middle of a print and you press down once, your options then are tune, control, pause print, or stop print. So if you click stop print, it's going to abort it. It's going to take it back to home. Now, while you theoretically can pause a print, in practice, I've never been able to successfully pause and then restart a print. If you pause a print, that top layer has started to get cool. It's cooling down, and then the binding that you get on that next layer is just never quite right. You can sort of make it work, but it's never perfect. Yes, Teresa.
Well, what I was worried about, and you probably get the same experience, is that you'll pause it to go back to home.
Yep.
So it has that reference. If you stop it, it will stop right where it is, and that could be a worst case scenario. It may not be as easy to extract, and clean up after, and start again.
Right. So she makes a good point. So if you select pause, the nozzle will take itself back to home. So it's a little bit easier to extract everything. Generally, what I would do is I would abort it. I would press stop, and then I would go into the axis control, and then I would just raise it up. And I found myself doing that even if it winds up at auto home. You end up needing to raise the nozzle quite a bit in order to get your hands in there and pop off the this bed. I don't know if y'all can see that, but this is magnetic. So the top of this is magnetic. And so when the print is done, you rip the whole bed off of there. And that's why we've got a second one going, is we'll be able to show that to you here shortly. And so generally what I found myself doing was it might be at auto home or it might be right above the object, but I would go into axis control Z, and then I would move it in 10 millimeter increments, and I would just move it up, 30 millimeters or something like that. And that would give me enough room to manipulate without burning my hand. Because if you wind up with it, because we've done such a good job bed leveling, right? When that nozzle is sitting right here, it is it's almost touching that bed, and so then if you start yanking on it, you'll struggle, and so that sort of brings up. I'll just rehash sort of the bed leveling thing again, and why it's important. The reason it's important is, as you can see on this bed over here, when y'all get up and look around, if you don't level your bed correctly, you can wind up damaging it, because the nozzle at 215 degrees centigrade ends up slamming into the bed and digging a gouge in it. And then when you go try to print the next time, there's not a perfectly flat surface. So that can be a problem. So that actually is that is a new bed. It's the second bed, and it's still just, I printed whatever 30 or 40 masks, and it just gets jostled a little bit, and I was being lazy and wasn't leveling the bed enough, and so you wind up with a $30 part that you have to replace. So that's sort of the importance of bed level. Okay, another question, because I'm talking too much. All right, what would you get if you mixed all light colors together? All the colors of light together. Who said white? Okay, congratulations. You have won. What would you like? We have clips, pigs, or puppy dog. Let's see how close this one is getting. So this print right here is at 86%. We will see if that one is successful. So as you can tell, we printed a bunch of these because we wanted to give you some. But what we realized was we had printed a bunch and we let them dry completely. And then we went to go and sort of break them free so you can use them. And nearly all of them just disintegrated. So it turns out for these clips, it's important that as soon as the print is done, you go and pull it off the bed and you try to free it up, because otherwise it solidifies. So that's, again, just one of those things that, you've got to learn a little bit. Yes. Oh, I think it was like 8 cents or something like that. What it is, so the print itself, and actually, if you come look at this, or if you look at this one close up, you can see that parts of it are just not connected, and there's just a small gap in between certain layers as it grows up, as sort of as it's printing. How does this do that? Well, yeah. So the designer designed an STL that allowed for that gap to allow the freedom of movement in that hinge. Exactly. Yeah, well, I mean, it is essentially two pieces. It's just, normally, right, you would probably attach, these would be two separate pieces, and then you would click them together. But because you're 3D printing it, you can sort of slip by that. You can just print it as one solid piece, and then there's just enough room in there that you can break it free and have yourself a chip clip. Yeah, so you'll see. So when I pull this one off, and we'll see if that one works. This one has a better chance. As I said, the red does a little bit better than the black. Yeah, so you'll pull it off of there, and you'll say, oh, it doesn't move, and you gotta sort of give it a. Yeah, exactly. Yes, it is. Although, as you can tell, I don't think that we were successful in freeing either of those. But I will certainly try that on this one. And the problem is, once it's sort of totally dried, it's a little bit tougher. But this sort of also goes back to the designer, as you were mentioning. You know, there were probably 10 or 15 versions of these that are out on the internet that are free, right? They're totally free. You can just go download them and you try it out. And it's like, okay, that one worked better than the last one. Oh, that one didn't work as well. So it's just trial and error. This just happened to be the first one that we found, and we printed it. And the first one that we did worked, and we were like, all right, that's a good one. And it, go ahead.
When you make a mistake, is that recyclable? Is there a way to get that back into a filament or thread?
That's a great question.
There are, I've seen in conferences, there are some, like, with chopping machines, you can get it, grind it up, and you get little pieces and parts that you use in molding. And, but then you got, I mean, there's a lot of processing, and you gotta, dump it all down somehow and extrude it into these strips and then wind it onto a thing. So you're better off just like bringing it from someplace that can recycle it. I mean, you can be as custom as you want to be.
Yeah.
You can buy and be, completely sustainable if you want to process all that yourself.
I mean, I think it's an interesting question, and it's important. The question was, maybe for the folks on Zoom that couldn't hear it, can you recycle your mess ups, right? So, this stuff, can we do something with this other than throw it away? And so the answer is, I think that there are places you can certainly recycle it. Because I haven't been doing it that long, I've been keeping all my mess ups to encourage me not to do it again, and they're sort of my tokens. But I think the one of the interesting things, and this is goes to sort of 3D printing as an industry versus like injection molding or cutting. So actually, these pair of glasses here are 3D printed. Now they're 3D printed using a very an industrial 3D printer, but as a result, they use about 90% less plastic than your average pair of glasses that are cut from acetate. So generally, glasses are cut from acetate, and it's about 90% waste. It's sort of like turning a bowl or something like that out of a log. You just wind up with a lot of scraps. And so one of the major benefits of 3D printing is that you shorten your supply chain. So you're not moving things through to warehouses, and then they're sitting there in cardboard and being packaged and moved. The supply chain is just from here to here. I mean, and really the only thing you are worried about is your mess ups. But all of the other sort of things that go with the modern manufacturing process are taken out. So I would be willing to bet that that one of these chip clips with 10 errors still has a smaller carbon footprint than one chip clip that was made in China and shipped here and stored in 5 warehouses and touched by 30 hands. So that's sort of how I think about it. And I will say I doubt that Red Lodge Recycling or Bear Tooth Industries. No, this is not in the shape of a bottle. So I think unfortunately in Red Lodge, I would just save it up and wait until you can send it somewhere else. Okay, another question. Oh, this is a good one. Who discovered the cause of cholera by mapping the cases of the London epidemic in 1854? Dr. John Snow, Dr. Stephen Rudolph, Dr. Hugo Munoz, or Dr. B.W. Richardson? Incorrect, but close.
What's the funniest thing?
Yep. So the answer is Dr. Jon Snow. This happened before Game of Thrones, so that is just a happy coincidence. Would you like another clip? He's mesmerized. Yeah. Yeah, and so, and if y'all want to swing by and look at this while this is mid-print, so one other thing you'll see in here is, oh, and this one is finishing. So one of the things you'll see is there's an infill option, and so infill is sort of, inside of this plastic object, how much rigid structure is there, right, as opposed to being hollow. So 0% infill would be hollow, 100% infill would be solid, and that solidness means more rigidity, but a longer print time. So you can see this one actually gave me some good spots. So what I'm going to do is I'm going to lift this up here, and I can just pop that off of there, and then try to free this. So free a little bit.
No, but it's not as set. So it's just brittle. I don't know why.
So that one didn't work again, and this has been our experience with the black ink. We have not been able to break a black filament free. Go figure.
I'm just wondering if we had done the best quality
Yep.
or the heavier, denser fill, we probably wouldn't have had that problem at all.
That's correct. So that one way for us to correct this problem would be a heavier fill and a higher quality. Exactly. Because what's happening is, instead of this joint breaking free, one of the arms is snapping off. So if we had a heavier infill, we would fix that problem. We didn't come to that realization until just now. So.
The only difference between them, the color, red and black, or is it the material? You get things, different grades, different usages.
So the answer is these are both PLA, 1.75 millimeter PLA plastic, and the only difference from a sticker perspective is the color. The red one, for whatever reason, they may be different manufacturers, but theoretically that shouldn't matter, but obviously it can. But so they are the same plastic, but there's a whole bunch of different kinds of plastic. There are some plastics that are antimicrobial, for instance, that became very popular, amidst COVID and the mask printing. There's also there's ABS, there's PLA. There's probably 10 or 12 different varieties, and they each have slightly different qualities. PLA is the least expensive, and it's what we've got here. But if you want to buy filament and bring it in and print something special, you certainly can. You just need it to be 1.75 millimeter plastic, and then just when you're in that slicer program, you just make sure that you've selected the right variety.
So when you were talking about the difference between the black and the red, you were saying, we should maybe try this. We were talking about instead of having a towel, or maybe this one is, fill it in more.
Exactly.
One step, and what was the other thing?
Higher quality, so a slower print speed, right? And it's basically just increasing the resolution a little bit. So the whole thing is all of the layers, all of your infill layers, your top and bottom layers, or have just a little bit more quality to them. Yeah, so those are your two options to get a better print. And then, so these are printed with 20% infill. So what we should do is just bump it up to 30 and see, if that's really good. And if at 30 it works every single time, then maybe we bump it down to 25 so we can save a little bit. But that is the way that I would go about that.
I had no difference in the two. They both ran very well, and they don't have movable parts, so I never did anything. It's that building.
Yeah, I think so. And for instance, some of the plastics are more flexible, and so those plastics might do a better job with these chip clips. But I don't, and I meant to say this at the beginning, but I'm not. The reason I'm qualified to teach the intro to 3D printing is because all I know is the introduction. That's it. And then after that, I challenge all of you to get better at this than I am. The internet is rife with information, YouTube videos, manuals about this, and people, even on like specific STL files, people have tinkered with it and said, hey, this worked a little bit better, this didn't work as well. You can go onto Reddit, find subreddits that are dedicated to these sorts of things, and there's the sky is the limit, really, and this really is just the introduction. I mean, there's quite a level of sophistication, but I think what's kind of amazing is that they've gotten to the point. These printers have gotten to the point where you can buy this printer for not that a couple $100, and you've got something that you can make a chip clip with, and that's novel. And even better than that, you can join here a steam engine, and you don't even have to buy the printer. We've got it here for you, and we've also got people who can help you along the way as far as we can help. So, got a couple more questions here. What is the first law of thermodynamics, or the law of conservation of energy? And this is a open-ended question. This is not a multiple choice. So if anyone can say off the top of their head the law of conservation of energy. So you're on a roll. Energy of this universe is constant. It can neither be created nor destroyed, but may be transferred from one form to another. Query whether or not dark energy or dark matter may change that, but that is currently the first law of thermodynamics. Yeah. Okay. Which of these groups invented fire escapes, windshield wipers, and bulletproof vests? NASA, women, the Princeton Science Club, or the New York City Fire and Rescue Union? You got it, Mike. It is women. We got two left. Oh, three options left there. All right. And I've got two more questions and two more. I've got two more questions and two more things. Okay. Who discovered the first computer bug? And this is multiple choice. We've got Albert Einstein, Alan Turing, Grace Hopper, Ada Lovelace. Anybody? Oh yeah, it was Grace Hopper, correct? You're okay? All right. And then our last question is, who was the first computer programmer? And our multiple choice options are Ada Lovelace, Bill Gates, Albert Einstein, or Grace Hopper. Lovelace, that's correct. Yep, it was Miss Lovelace. And both of those questions came from our Master of Ceremonies in the back, Stephen. Thank you for those. And I think with that, we're we're done with sort of what I had prepared, but happy to take any more questions. If you want to come up and check this out, or if you want to play around with the Prusa slicer, any of those things are fine. So I personally have made a lot of masks, and no, I should have brought one. Do we have one, Teresa? Okay. Yeah. So you can see a whole bunch of things that have been printed over the years. But so I printed a mask. It was through the it was a Billings neurosurgeon that designed it with a Billings group of students, and it got tweaked. But basically, it's a plastic piece about like this that covers your mouth and nose, and then it's got an insert, and you can put N95 material over it, but just a small square. Okay. Well, no, and this was what you had to do. So these, you would print them, and then you would submerge them in almost boiling water, and then you would put it up to your face, and you can mold it perfectly to your face. And then the benefit of it, or the thinking at the time, was that we were running out of N95 material, and so you could take one N95 mask, and you could get 10 uses out of it by cutting out enough sufficient to fill this mask. You're basically just reducing the amount of N95 material that you would need to sustain a hospital. And so it was, yeah. So if you can imagine, well, no, what it was it was a square hole, and into the square hole you inserted a square clip in that also was cross braced. So you would clip that in, and so you had mask material all in there. And yeah, it looks sort of like a Darth Vader mask. Oh, there you go. Perfect. Perfect. That was a much better job. Yeah. Yeah. So we printed, I don't know, 20 years plus of those for for Red Lodge Fire Rescue, so that they would have extra in case they ran out of. Yeah. Well, I printed some. Right. Exactly. Right, and so yeah, that's the benefit is you basically assign one of these to each person, and you've got a, essentially like a woodworking mask or something like that, but the filter material is just more easy to come by. You just cut up an N95 mask, and you can use that as the inserts. Yes, well, I dropped them off, and then they, as they assigned them, they molded them themselves. Yeah, I think you can remold it. I did mine twice. I'm sure there's a number of times after which you stick the stuff in almost boiling water and it wants to give up. But yeah, you can do it multiple times. And that actually might be a way to break these loose. Would be throw them in almost boiling water. I tried microwaving and that did not work. Yeah, toast, exactly. Yeah, so if you want to come take a look, you can see right now sort of how the separation between in the hinge itself.
And that part won't change when you change the info.
No.
There's still just those few little hairs in between, so that's a good thing.
Right, it should not. If you remember when I had the sliced version up on the screen, you had the yellow and then you had the red. That sort of showed you, and if you go layer by layer, it'll actually, there's a color key within the slicer, and it'll tell you what those colors mean. And like one of them will be infill, and so you'll see like, okay, this is the infill. This is what I'm beefing up, and it'll sort of get you'll see that color get denser.
Am I seeing a break on this one here? See how it's away from it?
Yeah, so those are going to get connected.
Oh, will that be the top one?
Yeah, exactly,
Okay.
exactly. Yeah, so you can see here,
Mhm.
it doesn't get joined until sort of the very end.
Yep. Wow. So whoever designed it knew what they were doing.
Yep. Or yeah, enough trial and error at least.
Noah, what do you think that you might be interested in printing? You could just come in and fool around with it, and just for the heck of it. I mean, someday when you think of something that you want to make, it's really good for prototyping, right? So if you think of something that might be useful, like the widget that they use for the seatbelts.
Right. Oh, that was another thing that we ended up printing. Yeah. So the cots, the EMS cots, end up with really long seatbelts. And so you can put somebody on the cot that's 400 pounds or somebody that's very petite, and you wind up with a lot of excess, excess material, and that ends up getting caught up in things, and you're in an emergency, and so it's all in the way. So one of the EMTs actually designed out of wood something that he could use to sort of roll up the excess material, except for when it's needed. And so instead of having to carve, 30 or 15 of them out of wood, he just was able to design it pretty quickly in a 3D design software. He sent me the file, and then I was able to print them for him. Yep, Matt Martin. Yep. And that was an interesting. Yep. Yeah, exactly. There's a lot of 3D design programs that are not AutoCAD, but CAD-like. Yeah, absolutely. And that's what he did it with, and it was an interesting print because he wasn't a professional designer. I had to mess with the infill, and there was also at first I tried printing it, as I told you, sort of with the largest flat surface down, but it turned out that printing it vertically worked better just because it had large gaps in it. And so if I printed it horizontally, it sort of ended up sagging down. Here, I'll draw. It was something like this. And so what he would do is you slip the seatbelt in here, and then you just roll it, and then you throw a rubber band around that, and that keeps it all secure. So at first, I had the bed like this, and I was trying to print like that. So what ended up happening was this part would sort of fall down, and it would never stay. It wasn't enough to stay totally flat. And so then I tried creating bracing in here, which is something you can do in that program. But then to cut out the bracing, I was like sawing on it, and all this stuff, and it didn't work. And so then what I tried was I just did it vertically like this, and this print ended up working like. Well, and so actually I did all those. So I did that, and then I also did this as well, like what you just said. So at first I tried this, and then I tried that, and then I tried that. And
the last one was
yeah, both of these were they were comparable. This one was like, I never got a good print, and these two were about the same. I found that this one I think this one ended up being quicker because the novel head didn't have to move as far to lay down that, it was making quicker movements, and so it printed a little bit quicker, I think, is how I went with there. So both of those were. So, an interesting side note on the mask So this insert here was printed separately on the map. So this was not actually in here. It was just a hole. And so both of these things were printed on on this platform at the same time. So I would have the mask going right here, and then this insert going right here. And you can actually see some of those ghosts on here. And I think if somebody was designing it better, they probably could print it all at once with the gaps, sort of like what we did here. But maybe so that's
I'm just kind of thinking,
Noah.
If you have something that has a broken piece and you've got the piece in, then you have to run out on your expensive coffee maker, then more expensive maker, and you want to make coffee and have, they have to do it all. Yeah, you could design a little knob, but you know how to make a little circle. So you could probably find a design out there already created, or you could create your own, like Walter said. Did they use AutoSketch or something like that?
Yep. Yeah, he did.
And just fix it up and then take it into that slicing program and sign all those other parameters. And so, yeah, I mean, it's pretty fussy depending on, if you're doing something from scratch or adopting somebody else's design or what you want to find.
Google. Yeah, I mean, there's a couple good websites, but Thingiverse is one. Yeah, but if you just Google around, I mean, there are so many of them. It's hard to say, but they're all similar in that for the most part they're free, and yeah, I just use Google and like so I just Googled. So I've got a 2004 F250, and I'm missing my light switch. It somehow got pulled off of there at some point, and so in order to turn on and off my lights, I have to like really grab on it. So I was like, well, I wonder if somebody else has already come up with that, and it looks like they have. So I could just go on there, find that, and print that switch and replace that part without having to order a new one or the whole the whole deal. Exactly. Yeah. So I'll just. So here is here's the Ford truck headlight knob that is available on what is this one, STL, right? So I mentioned so that the file name is STL, and so here's an STL for a Ford headlight knob, and that's sort of endless, right? You could go and you could print a new knob for your oven, right? And the best thing to do is just Google and say, here's my Kenmore oven, and see if somebody's already made it. And if they haven't, it's going to require a little bit more work. But chances are, if it's something that's somewhat common, somebody's already done it. And that's sort of the beauty of it. And they're all out there, and they're all, for the most part, free.
You can get filament that goes with it. If you've got an application or something, you need to see a clip that's dark, where's my flash light, where's the holder might be showing dark material. You can do all kinds of stuff.
And I think one thing that might be interesting, like for you, is if you go and look at the different types of plastics, there might be one that's good in the cold, and it could be a repair for something sort of skiing related, right? It could be the applications really are endless if you're willing to sort of just go and look, just Google around, really. I'll end on one little vignette. So when I was in college, I did like a work study program. This is, I guess, over 15 years ago now. And but I was in the IT department. Well, I didn't really know anything about computers, but I just knew how to use Google pretty well. And you know, it's true about computers. If you've got a problem, somebody else has probably had it. And if you know you've got something you want to print, chances are somebody else has done it. And if something's not working, we're here to help. But also Google is, and it really is in this domain especially. It's just really you know, it's just invaluable. Yeah, it's just it really is. It's endless possibilities, functional things. I've seen you know, you can print an iPod charger or an iPhone charger or cell phone charger. You know, like a stand that you put it in, and you can flip it in, and that way you can look at it. I've also seen ones that there's a pretty cool little stand that you set your phone in, and it amplifies your speakers. So it's got like a, you know, it's just catching all that noise and sort of like redirecting it with a funnel. And I mean, endless sort of cool things that are useful, and then again, endless parts that you may need to replace that aren't you know, super high tension. But when you get into high tension, there are 3D printers that will do that. There are 3D printers that will print aluminum. So you can a lot of aircraft parts now today are printed on 3D printers, and the reason is because they can make them lighter weight than they can by forging them or by injection molding them. Or the injection molding process just doesn't produce as strong of a process. So, you know, even in sort of advanced aerospace realms, you know, they're moving into 3D printing, and it's about the cost savings and sort of what I talked about, the supply chain. You're shortening the supply chain so much. All you need is this one raw material, and then you've got everything to make it right there with you. And so it's going to be interesting to see as it develops. And you know, I remember my dad's first printer in, I guess, like 1989 or something like that. And it had like the ribbon tapes on the side and the carbon copy, and it, you know, it was like $2,000, and you had to run it through MS-DOS, and you know, sometimes it worked and sometimes it didn't. And so I think of this as something like that. Like it's still early, but if you've got the skills to, or if you've got the wherewithal just to come and apply it, I mean, the opportunity is pretty extraordinary, and especially as you get into nicer printers. So.
Well, Steven wants to learn more on the laser cutter and vector. We could do a lot. There's a list of things that we have people that we've identified in our community, and then also connect them to email and their careers, their hobbies, their skills. For example, Jennifer London from community and sharing her knowledge of bodies and taking people out in the field. She wants to come back in and show people how to tell some of the more detailed differences between some of the plants that we do find out there. And so that you, by sight, you can dissect them, look at them under the microscope, start breaking it down to identify them further. So there's people with so many different
How does your knowledge fit into the steam program? What do you put in?
Okay, so what is steam?
Steam.
Stem doesn't matter. Steam is stem with an A. Art, right? You add art. Art is more like it's collaboration. So for her, that's all art. Right? So
He's not actually coming in and sharing like a certain piece of equipment like that.
yeah, I mean, we might have to borrow these things, but you can certainly sit up front just like Walter does.
But it's science.
Right?
Yeah.
So steam is everything except for the science. Right?
I guess I was looking at, we learned how to use a piece of equipment here, and I was thinking that's what the workshop was going to be, learning certain equipment, and then our imagination could say on how we can use
We
it.
just had an introduction and you are no welcome for some of you doing what we
But that's why I'm asking you, what are some of the other pieces of equipment? You talked about the laser.
And right now, what we have is two printers and this laser cutters, we have the garage band, the digital piano. We have those PCs and the Arduinos set up for programming. We have
I'm just familiar with Arduino.
we have a telescope that we go to borrow or come in to use on different, pieces in the sky or, just their interest. We could have somebody come in and read a sky walk. We could have someone come in and, next time there's a big event, come in and perform that. I'm not sure what you're looking for. You're asking for a list of what we actually here.
Yeah, I think I am just, like I just mentioned that, you share the Arduino. Is that what you have to?
Here, we have our little programming kits that come with sensors and motors and users and programs. They come in order to interface with the box and pieces of robotics that the kid would manufacture and then program and then compute it. So that's their skill building. There's their kits that we've already purchased for that purpose.
See, that's what I'm kind of talking about. Like, when you explain to me that somebody like myself has never worked with directly, I think you can learn how to do that. Because it involves some treatment.
Right, and if you want to, there's an Arduino, like introductive kit that has all different types of sensors, things that you could learn how to program to get the reactions that you could, your programming to test. You're really going to learn how to perfectly customize things, leading to, the learning and how to use it.
Right?
The pictures are listed on the website, and yeah, so there we want you to test it. That's good.
The other thing that's coming is we're going to have a audio booth in here, in this closet right behind us, and it will be for StoryCorps. But also, if you want to come and record podcasts, that'll be an opportunity. Video blogging, that sort of thing. We'll have a little studio in here. And then, I would just note, with computers, if you get into software programming at all, as Stephen will attest to, there are billions being made. Just with a laptop is really all you need. And this this machine up here and sort of getting into it. And I'll just on the STEAM part, I think it's great that that name was chosen and not STEM, because it says science, technology, engineering, arts, and mathematics. And the art is really important, because I think at the edge cases, when you find people who are super gifted in science and technology, and engineering and mathematics, they're super creative. And I think that's where the art is, where it comes in. There's art, and then there's like art within science that's also possible, and those can overlap. And so, I think the other thing we've talked about is, we can have a painting class in here. We can have somebody come in and talk about how colors work, and how art interfaces with the world, in theory, and that may apply to some young minds or some older minds in their thinking about how to apply science and technology.
And the introduction to art is really, I think that everybody likes the inspiration of graduation. A lot of times there's that, like you said, you might have no talented person artistically, they can express something like way out. And then they have in order to connect it or get it to move into animation or into some other media or format or thing or design for even cool, you can be very artistically designed so that it's more pleasing to handle even or look at it. So there's a lot of collaboration, I think, that comes from combining art with the rest of it.
You can't see, but I'm smiling.
Well, we're trying to run it without membership and fees and see if we can keep this funded through donations and nonprofit. What we'd like to do is see if we can help people, like if we have an understanding of what people want to do, we can tell them this is what material you might need, or we could purchase it for you if you can pay the fee to cover that. But we're trying to keep it so that it's open and available to as many as possible.
Donations always welcome.
Yeah. And the other thing that we did, so I was taking a couple of photos
Cool. And one thing, Stephen, do we still have the 3D scanner? Didn't it have a 3D scanner?
Oh, what
Okay.
it's just like a point measure I wanted to do this point, but you could put
Right.
The one we use for box.
Yeah.
Or, you know, person. That was the that is a program that we got online too. But it was more like a Kickstarter type thing, so they started charging for it. So there's still, I mean, if you have an education that does produce something that you can't get, or if you feel like, you know, there's something you really want to use in here, then maybe we can look at it. A lot of applications are moving to the fee for use, you know, model. So we could actually keep the software and just let somebody pay for that time. There's a lot of things that are done that with the assessment versus the heavy or costly.
The red one didn't give either. Disappointing.
Yeah, I think we lost our touch. We started out really well. 6 in a row, no problem. Yeah.
Yeah, I'm definitely going to come back and try different insoles. We'll let you know.
So we know the you know, we had our hard decisions like we're doing that to the focus here. We had everything under the sun and piles and piles and piles and endless possibilities. But we just had to really say, I know there's been a lot of confusion about which one, you know, things that are both there. And it's also really intimidating to have people who really understand, you know, how to use it. It can be scary, right? So that's the idea behind presentations and workshops is to get everybody more tuned into what's possible here, what people have to share, and to see what you might be interested in. You know, a lot of these things might be, you know, taken up as hobbies for people. They're certainly not going to become career changers, but it's, you know, like if you go to a DIY, do it yourself, or a makerspace, that's the similar concept. Is come in and explore, see what you want to do, see where it leads, right? Learn something.
Well, this is wonderful. Thank you.
Yeah.
I saw some really cool, I want to do like planters. And I saw a really cool one and they're kind of geometric, kind of hollow, and they stack on each other. And the way that the drainage holes are is it'll drain into the one below it. And so like that's something so you're not just like pouring out.
Yeah.
You know, but I think that's
Absolutely.
Take
So,
two pieces of plastic
I think I
and
like
carve
it.
and whittle and file and whatnot.
Yeah.
Have something to put together.
Thank you.
It's
Thank you.
gonna take a lot longer.
Walter.
Yeah.